Welcome back to another design patterns video. I'm glad to have you here. And in this video, we are simply going to pick up where we left off in the last episode. And just as a reminder, what we did in the last episode is that we implemented the observer pattern in C#. So again, we're looking at object-oriented patterns for object-oriented languages, but we're using a statically typed language, which is then C#. But of course, you can use a dynamically typed language, and you can use another statically typed language that isn't C#, of course, like for example Java. But anyways, what we did is that we implemented the observer pattern in C# with an example, like a hypothetical example. And what I mentioned in that video that we're going to do in this video is that we're going to use the facilities that the .NET frameworks We're going to use the facilities that the .NET framework for C# provides us in order to simplify the implementation of the observer pattern. So again, as I mentioned, that some of these design patterns can actually be extracted into or turned into sort of framework, library code, right? That can be used by you or by anyone to essentially. Some of these patterns can be turned into reusable code that can work across scenarios, and some of the patterns can't. So for example, then the observer pattern is one such example. I mean, iterator pattern can also be sort of reused across scenarios, and visitor, if I'm not mistaken, can also be reused across scenarios. So, so this is hopefully going to make more sense as we dive into this, right? But the point is that we're essentially going to take exactly this code that we had in the last example, right? This is the code that we had from the last video. I'm just picking up where we left off. Actually, we can fix this one typo. I wrote prepend here, but of course I meant pretend. So anyways, but it's essentially the same code that we had last time, and we're going to quickly read through this documentation here that we have in the .NET docs, essentially, on how to use observer pattern in C#. So I mean, just glancing over this very quickly, we can see that you have the interface IObservable, and we have the interface IObserver, and you can see that you use this. We're using this T, this generic here. And so, or generic type parameter, I should say. I'm not going to talk about generic type parameters, or generics, essentially. But if you want me to do a video on that, say something in the comments, and maybe we can do something on that. I mean, it's if you're from a Haskell background or something like this, I guess this is like roughly the same thing as parametric polymorphism. It's saying that when you define something so there is an interface called IObservable, and there is an interface called IObserver. But whenever you create an implementor that implements IObservable or IObserver, they also need to specify which T they operate on. So more specifically, what wait, I'm realizing I have to turn off notifications here. Hang on. Do not disturb. Okay, solid. Wait, no notifications here. Super good. Okay. Okay. Yeah, but whenever you implement the interface IObservable or IObserver, you need to specify under what T this thing operates, or on what T, on what type this thing operates. So this is going to make sense as we dive into it, right? But let's just start to read here, right? Roughly, let's skim through this, right? The observer design patterns enable a subscriber to register with and receive notifications from a provider. It is suitable for any scenario that requires push-based notification. So this is all stuff we know, right? It's like, this is the observer pattern, essentially. Blah, 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 blah. And I guess, yeah, the provider automatically notifies all observers by calling one of their methods. In the method call, the provider can also provide current state information to observers. In the .NET framework, the observer design pattern is implemented by implementing the generic IObservable over T and IObserver over T interfaces. The generic type parameters represent the type that provides notification information. This, I think, is actually kind of poorly written, because I understood this first when I read this as that T refers to the observable, the concrete observable, but actually it doesn't. That's not what they mean. What they mean is that it refers to the data that you get when you observe an observable. So in our case, that refers to, for example, the weather data, right? Think about our scenario. We have a weather station, and that's the observable, and then we have a weather data printer and a weather data aggregator, and both of these are observers. And when we're talking about T, we're not referring to any of these. We are simply referring to the weather data, which is the data that's being passed from the weather station to, for example, the weather data printer or the weather data aggregator. So it's the weather data that's passed from a observable to the observer. It's the weather data that's passed from the observable weather station to anyone observing the weather station. So that's what they're referring to with T here. And then, yeah, they have some more information here about when to use this pattern. And then they're saying essentially, I mean, here they're discussing the pieces of it, right? You need a subject, you need an observer, and then you need a mechanism that allows the provider to keep track of the observers. So they also use the term provider to refer to the observable. So a provider or subject, right? So provider, subject, observable, same thing. So a provider or a subject or an observable, right? That's the thing that sends notifications. And then observers, and then some way of keeping track of the observers. And then here's a pretty interesting portion, but we'll get to this. The observable also need an implementation of IDisposable. So they're not actually using this add, so that we can add observers by saying add, but we can't remove observers by saying remove. The interface says that whenever you add, you should get back a disposable that you can call in order to remove that particular observer. We'll get to this in code, right? This is an interesting choice, and actually there's a Stack Overflow post. I forgot to pick this up, but I can put that link in the description. There's a Stack Overflow post discussing why this is, and I think that post has some interesting comments. I would highly recommend you read that, right? Because it's not obvious why they made this decision as opposed to just having a remove method. And then an object, and then you also need an object that contains the data that the provider sends to the observers, right? So that's, again, we're talking about the weather data. And also they're mentioning then this, that although this object can be the same as the IObservable T, so it could be that when the weather station tells the weather data printer and the weather data aggregator, so when the weather station tells its observers that it has changed, it might simply pass itself, right? That's one possible scenario. And they're saying that although this might be the case, most commonly it is a separate type. So, okay, let's just dive into it. And then they have a bunch of examples here, right? But we're going to use our own examples. So yeah, so let's just dig into it. So here we have this code from last time. Let me just map some keystrokes to saying MCS of, this is called program.cs, so that we can compile the file, and then I'll map another keystroke to running this through the exe file that's returned through mono. So let's just make sure that this works. So I can compile the file and I can run the file, right? Sorry, this is some old stuff from before. I was just looking at the output of that file. But here you can see the output of actually running that file. Temperature, running average, temperature, running average. And again, like if this doesn't make sense, check out the last video, because this is all stuff that we discussed in the last video. So how do we do this? Well, I guess since we are going to use their interfaces, I mean, maybe it just makes sense to start deleting our own interfaces. So we have this interface that we designed, IWeatherDataObserver. Let's just delete it. Gone. Okay. Where do we have another interface? We have IWeatherDataObservable. Okay, cool. Let's highlight that and delete it. Okay, so those we supposedly shouldn't need. We have no more interfaces, right? Let's remove this stuff also, because that's just a comment from last time. So now we only have the concretions, but we're depending on non-existent interfaces. So we're saying that we're implementing non-existent interfaces. So if we compile this, this of course doesn't work because we don't have that stuff in our namespace. So let me just go to the top, and then we'll scroll down and see where's the first. Let me just search for I was looking for the first place where we refer to an interface. So this is the first place where we refer to an interface. We're saying that the weather data printer is a class that implements the interface IWeatherDataObserver. Okay, so then we are talking about from a C# point of view, from a .NET point of view, of an observer. So notice here, IObserver of T, right? So this should be IObserver of what is the T, right? We said it's an observer. Sorry, wait, let's before I write that, let's think about this. It's the weather data printer, so it's an observer, and it expects to get weather data. So of course then it's observing incoming weather data, and hence it needs to be an observer of weather data. Hang on, let me let the cat in. Okay, let's keep going. So it's an observer of weather data, and I'm realizing, let's just let me jump out here and see. Previously we had 1, 2, 3, 4, 5 errors. Actually, I mean, I can't do that. I was going to say if we start to compile this, we should have fewer errors. 1, 2, 3, 4. Yeah, okay, so that is the case, right? Because that thing actually does exist, but we should have some issues surrounding, I guess, that we need to import that as well. Like we need to have a using statement for that. But anyways, let's say IObserver weather data, right? And let's go through the other interfaces. So the weather data aggregator is also an observer. So then we need to say IObserver of weather data. But and that's fine, right? I mean, it's the same thing. It does the same thing. It's an aggregator that observes weather data. It's an observer that observes weather data. Okay, where's our next interface? Here. Okay, iWeather data observable. So now we're in the subject, or the provider, or the observable, right? So here we need to say it's an iObserver, right? So we're using this interface, iObserver. And it's an iObserver that will provide weather data. So here we can think about it from the other perspective. It's like we're saying weather station is an observable, so you can observe it. And whenever you pass an observer that's supposed to observe this thing, what you will get back is weather data. And then you can see that this sort of lines up, right? Because the observer provides, the observer manages subscribers and notifies them of changes of weather data, and then the printer and the aggregator here, they are both observers that observe and will get weather data. So if these were different things, then they wouldn't be compatible, right? It's because we are using weather data in all of these places, or if we would use something that yeah, I mean, because we're using the same type, right? I was thinking we could of course also probably do it in some kind of polymorphic hierarchy, right? So maybe they're not exactly the same type, but they are of the same parent, and the yeah, maybe not actually. Let's not think about that. Yeah, it works because they are of the same type. Okay. So do we have more calls to? Yeah, we do. Okay. So iCollection, iWeather data observer. So here's where we're saying we have a collection of observers. And where this collection is of iWeather data observers. So this, of course, need to be, sorry, let me, for the sake of saving space, can I say var here? No, maybe I can. Yeah, maybe I can, whatever. Let's say. So if it's an observer, if it's a collection of observers, then it's a collection of iObserver over weather data. I'm not sure if over is an appropriate term to use here, but I think it kind of makes sense, right? And then, of course, we instantiate that as a list of here we have iWeather data observer before, but now we need to have iObserver over weather data, right? And this one is fine because that's concrete. But then let's look for the next instance of an interface. I mean, instance of an interface, the next occurrence of an interface in our code base. And that's here, right? We're saying whenever we add an observer, we want to we are referring to, or we want to be passed a iWeather data observer. So actually, I think what I'm gonna do, because even the names are even, no, let's sort this out. So whenever we're passed an iWeather data observer, and that's of course the same, we should use the same type as we have here, right? Because we have a collection of iObservers over weather data. So whenever we add an observer, we should of course be passed an iObserver over weather data, right? And then notify, that takes weather data. And then here for each, yeah, so here maybe we just do var. I think var is fine here. So of course, but of course this should be iObserver over weather data, because we're iterating over all of the observers. Okay, do we have more interfaces? No, that's it. Okay. So let's save that and let's try to compile it. Of course, it's not going to work, but let's see where we're at. Woo, 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 woo. Okay, so this is what happens when you're like refactoring code by just changing it. This is why we don't want to change code, right? We just want to write new code and trash old code. But anyways, that's a totally different discussion. Okay, line 27, weather data printer does not implement the interface member IObserver weather data on next, right? That makes sense if we start to read this documentation actually. And if you look at it, we have on next, and then we have the same error, the same error for on error and for on completed. And these are all for weather data printer. But then we have the same ones, on next, on error, and on completed for weather data aggregator. And then what do we have more? Then we have observer over weather data does not contain a definition for update, right? So essentially, and then on next, on error, on completed, right? So essentially what all these errors are about is that we're saying that weather data printer is an observer of weather data, but we're not actually implementing what is required to be an observer. And so if we check out the observer, observable, observer T, right? Can we get the information from here? Yeah, I mean, we could go into the documentation, like we could drill down here and just look at all the details from this page, because then we can see, we should be able to see that you have a type parameter T. I thought there would be like definition, examples. Wow, I am confused. Methods here, sorry. Yeah, so it's saying you need to implement on completed, on error, and on next. And that's the same thing that we can see here, on next, on error, and on completed. So, I mean, you have roughly the same information, so I'm just going to stay on the observer design pattern page to simplify things for us, right? But you need to implement on next, on error, and on completed. So let's do that, right? And actually, if you think about it, update, what we called update before, is actually the same thing as they call on next. And it needs to take something of type T, probably. Oh, okay, we don't actually have that information. On, yeah, if I jump over back here, right, to the actual documentation page for observer, IObserver, then you can see that on next takes something of type T. And that's, of course, then weather data, right? Because this concretion weather data printer is an observer of weather data, so whenever we have a next piece of information, that piece has to be of type weather data. But then we also need to have public void on error, taking an exception, E, and then we need to have some implementation for that. And I mean, let's just say console write line exception occurred. This is a really bad implementation, right? But I mean, it doesn't really matter. It's the point is you have the ability to, from the observable, tell observers that an error has occurred in the observable. So the subject, the weather data, can say, for some reason I've entered an illegal state and there has been some kind of problem, right? Like there's an error, and I need to notify all my subscribers that there's an error. So that's what you can do with this on error method, or that's why you would use this on error method. And then you would have on completed, for example. So public void on completed, and it takes no arguments. And it here, I mean, if we read the description here, it says notifies the observer that the provider has finished sending push-based notifications. And maybe you remember, as we talked about in the last video also, like you can also think of observers kind of like streams, and then this sort of makes sense. It's like maybe you're constructing an observable that starts to send data, and eventually it runs out of data to send because it's finished its job or whatever. Like maybe you have a file reader observable. This maybe doesn't make any sense, but like hypothetically, and then you can keep observing it, and it will pass you line by line by line, but eventually it runs out of data, and then it will say I'm completed, so it calls on completed for you. So let's just say, I mean, console write line completed, or let's just say weather data. This is the printer, right? Yeah. So completed, or let's say maybe received all data from weather station. Maybe that makes more sense, right? And then I'll just copy these, right? Because we want to do something very similar in the weather data aggregator, right? Because here we also need implementations for these methods, and actually, I mean, here we have on next, right? And again, we said onNext is essentially the same thing that we called update. So weather data aggregator also, of course, had an update method. So we'll just call that onNext, and then I'll remove this onNext, right? Because this is our implementation of onNext in the weather data aggregator. And then we have onError, right? So I don't know. I mean, depends on our scenario what we would want to do with this. But here, maybe we would say something like error has occurred, and then we say true or something like this, right? So we'll say there is a Boolean called error has occurred, and that's instantiate or initialized to false. Hang on, cats. Yeah, they don't like closed doors, you know. So error has occurred, we set that to false, but then whenever an error occurs, we set that to true. I mean, it doesn't really matter. The point is, or the point I'm trying to make is that you would supply an implementation here that makes sense given your scenario, of course. But then, and on completed, I don't know. I mean, again, like here, maybe it doesn't really, yeah, I'm thinking like, I don't know, maybe we don't even do anything, right? You could, or actually, maybe instead of doing get average, let's just do this. Let's say console write line. No, but that doesn't make any sense. Yeah, doesn't matter. Let's just not do anything, right? On completed for the moment, right? But what you might want to do if you have something like this aggregator, right, is that maybe you're computing sort of intermediate. Yeah, I don't know. Like, let's say you have something that's dependent on the total length. Yeah, but that could be calculated all the time. For some reason, you have something that can't be computed until you have, like, actually all the elements, and then you could perform that calculation in onCompleted. But I don't know. I mean, this is a hook in some sense that you can hook into in order to do something whenever the execution has completed. So let's just see. I mean, we still have pieces missing, right? But let's save this and try to compile to see where we're at. Like, of course, we have tons of less error. There's lots of less errors. Anyways, less errors. But let's see. We still have an error here. 73. Okay, cat balls. Yeah, we'll see if that works. So 73, IObserver does not contain the definition for update and no extension method update of type IObserver weather data could be fine. Are you missing an assembly reference? Wait, 73 here. Oh, okay, sorry, because our weather station now attempts to call update on our observers, which was fine before because we said that they were weather data observers or something like that. But now they are not that. Now they are IObservers. Well, I thought I pressed do not disturb. Do not disturb. Who knows? Maybe I turned it off. Silly. But now they are IObservers over weather data. So then they follow the IObserver interface, which means that these three methods are the only methods that we can be sure that they have. So what we need to call is that we need to say onNext and then pass the weather data instead. But I mean, it's essentially the same thing as calling onUpdate. It's just that the contract has changed, right? Like the name of the method that we were previously calling update is now actually onNext. Okay, so that's one error. Let's move on. Okay, next one. Weather station. So now we are at the observable rather than the observers. The weather station does not implement interface member onNext. Okay. Wait, weather station. 60. Did I make an error here? Ooh, sorry. Somebody stop me. I said that the weather station is an observer. I should have said it's an IObservable. Apologies. Hopefully some of you caught that. It's an IObservable, of course, right? So the error should be, let's look at this. Weather station does not implement interface member subscribe. That's what the error should be, okay? Because the weather station is an observable, not an observer, of course, okay? So what was the error? They were saying it doesn't implement the interface subscribe, so it doesn't implement the method add. And it's not about adding data, right? Because that's something that we added because we want to be able to fake incoming data to the weather station. But it's actually this thing. It's add observer. So yeah, maybe I don't Yeah, maybe we can just say this. We'll just rename this to subscribe. By the way, do subscribe to the channel so that you won't miss the next video. Plug. Okay, anyways. Public void subscribe, and it takes an IObserver of weather data, and roughly this, and sorry, not roughly, it has exactly the same implementation as before. This is not going to work, but let's look at the error, right? So the other error is that the weather station does not contain a definition for okay, so sorry, this is an error in another end, but let's solve that first, right? Because on the concrete level, line 14 is here calling station.addObserver, and notice station is from here, so that's an instance of weather station. But now we can't say addObserver, we now have to say, actually let me change both of these at the same time, we now have to say subscribe, right? Again, because like we've actually changed the contract. So since weather station is of type or actually here it's of type weather station, right? And since if we go to weather station, since that has a method called subscribe, we need to call subscribe rather than, what was it before, addObserver, right? Let's compile that and see where we're at. So weather station does not implement interface member IObservable subscribe. Yeah, okay, so this is the error I was actually looking for. So now we're back to line 60, which is here. And then they're saying that we're claiming that weather station implements the interface IObservable weather data. But the compiler is saying you don't actually do that because you haven't implemented the method subscribe. But we're like, wait, what? But I mean, we've implemented the method subscribe, right? Here's our subscribe method. But actually we don't, or we haven't, because let's look at it here. If we go to observable T, and let's go into the documentation here. We have to check what the contract is for subscribe. So methods, the method subscribe needs to, well, how am I supposed to see this? I mean, I know what I'm looking for, but where can I actually, well, this is a bit silly. Do I have to click this? Yeah, okay, so sorry, I have to click that. So the method subscribe here, like we need to have a subscribe method that takes an IObserver over T. And the taking an IObserver over T, that part we've figured out, right? That's this. We've got that part. But the part that we don't have, if I jump into subscribe here, you can see the part that we don't have is IDisposable. So IDisposable, or I mean, the return type should be IDisposable. So that's what we talked about when we said that the subscribe method should return an IDisposable on which we can call dispose in order to dispose, in order to unsubscribe the observer that we just subscribed, right? So whenever you call subscribe on the weather station, or let's say more generally, whenever you call subscribe on an observable and pass an observer, then you should get back a disposable, such that if you call dispose on that disposable, you will unsubscribe the observer that you just added to the observable, or that just started to observe the observable. And I'm not going to go into tons of details, but I mean the reason for, no, actually, I mentioned that, right? The reason why you would want to do this instead of, for example, having a subscribe and an unsubscribe method is open for debate, I guess. And there's again like a great Stack Overflow post on that. But I think one of the great points was that whenever you want to unsubscribe, the one who wants to unsubscribe has to keep track of the observable and the observer. Like the observable, the observer is subscribed to, and the observer that is observing the observable. And it needs to keep track of both of those whenever it wants to perform an unsubscription. But if you do it this way, here, like in the documentation where you return an IDisposable that you can call dispose on, that means you only have to keep track of that one thing. So you have to keep track of that one thing in order to unsubscribe the observable. And that's actually like a fairly good point, right? Because then you can think about it as, maybe you've been watching my functional programming series in Ramda, and we've talked a bit about like having arguments that take a single argument. When you have a function that takes a single argument, it's much easier to work with that thing because you can put it into a pipeline and just sort of pipe values through functions and successfully transform values, like from one original input value to another output value. So there's definitely some power to that. So yeah, I mean, from that perspective, I think that probably makes a ton of sense. But anyways, okay, so our next step is to figure out how to use this IDisposable. But actually, I'm currently running out of time, so I really have to go now. But again, remember to subscribe, and we will pick up where we left off now in the next video. Thanks a ton for watching, and yeah, let me know if this makes sense to you or if you have any questions, and hit the like button if you appreciate the video. I will see you in the next one. Thanks a ton for watching.